Hello everyone and welcome back to another video from Maths Problem Solving. Today we're going to be looking at an SMC problem, which is an Algebra 1. So here's the flowchart for it. And we basically need to work out what the value of x times y times z is. Now, there are broadly two approaches you can use. There's one which is kind of impractical in an SMC environment, which is just multiplying everything, just kind of using brute force really. It's very slow, but we'll be looking at an alternative mechanism which you can use to, which is much quicker to work out what the value of x times y times z is. So yeah, let's just get into the question. So we have three values, x, y, and z, which are all quite unpleasant, like when you look at them, you know. But if we just rewrite them like this, so x can be rewritten as a minus b minus a plus b, right? So in this case, a and b are 12 and 3 root 7 respectively. And we can rewrite all of them, y as well. Like y equals the square root of c minus d minus c plus d. And z as well. E minus f minus e plus f. And we need to work out what the value of all of these multiplied are. So all of these things have a square root inside them, and square roots aren't particularly pleasant, so we'll need to try and remove that. And obviously the way you remove square roots is the square. So let's just write x squared over here, okay? So x squared basically equals the square root of a minus b minus a plus b. The square root of these, I should say. So let's just expand this out. We know that the square root of a minus b multiplied by a minus b would just give a minus b. And the square root of a plus b multiplied by the square root of a plus b would just give a plus b. Plus a plus b. Just need to be a bit careful with the negative signs here. But yeah. And now we know that the square root of a plus b multiplied by the square root of a minus b twice would give minus 2 a minus b a plus b. Okay, let's just clean this up a bit. So 2a minus b plus b, they both cancel out, minus 2 the square root of a minus b times the square root of a plus b. Now there's a way we can write this a bit more concisely. I'll just write it like this for now, but if we consider two square root terms, like let's say the square root of x times the square root of y, we can rewrite that as the square root of x times y, both inside the square root sign. So surely we can rewrite this like this, 2a minus b times a plus b. Now this is just the difference of two squares, right? A minus b times a plus b. So we know that this will basically just equal this, a squared minus b squared. So that is a way to write x squared, 2a minus 2 the square root of a squared minus b squared. Now since all of these are of the same format, the square root of c minus d minus the square root of c plus d, we can rewrite everything like this, right? As 2 times the first term minus 2 times the first term squared minus the second term squared all square root. Let's just substitute the values of a and b back into this value of x. So the value of a was 12 and the value of b was 3 root 7. So this just equals 2 times 12, 24, minus 2 times 12 squared, which is 144, minus b squared. B was 3 root 7, right? So b squared is 9 times 7, which is 63. So that equals 24 minus 2 times 144 minus 63. So a bit of 79, no, sorry, 81. Yeah, that's quite clean. 2 times the square root of 81. Square root of 81 is just 9, so it's 24 minus 18, which is 6. So that's x. X squared, sorry, then that is x squared. Let's just write x squared equals 6. We'll just use this to keep a track of x squared, y squared, and z squared. So now y equals the square root of c minus d minus the square root of c plus d. We don't need to go through all of this algebra again, right? Because it's exactly the same format. So if we basically just take in this step, we know that it's going to be of the format 2c minus 2 the square root of c squared minus d squared. All of that's going to be y squared. And now let's just substitute c and d back in. So in case of y, c was 7 and d was 4 root 3. So this equals 2 times 7, 14, minus 2 times the square root of 7 squared, 49, minus d was 4 root 3, right? So 4 root 3 all squared is 16 times 3, which is 48. And this just simplifies very cleanly to 2 times the square root of 1, which is just 12. So therefore y squared equals 12. Hopefully you can see that this is like a much quicker and cleaner approach than just using brute force as we discussed at the start and just expanding out everything normally. So yeah, well, we need to use the same principle with z squared. So z squared equals 2e minus 2 times the square root of e squared plus f squared, minus f squared, sorry, minus f squared. I'll just rub some of this stuff out just to give a bit of space for us in our working. Delete. Yeah. So let's just go back. The values of e and f were 2 and the square root of 3. So this equals 2 times 2, 4, minus 2 times 4, 2 squared, and root 3. Root 3 squared is just 3. So this equals 4 minus 2 times root 1, which just equals 4 minus 2, which equals 2. So z squared equals 2. Now let's just go back here. Z squared equals 2. Now we have x squared, y squared, and z squared all over here, and they're all like nice numbers, you know, all integers, and here. So let's just work out x squared times y squared times z squared. Because if we just square root this, we'll be able to get x times y times z, which is what the question is asking for. So this is 2 times 6 times 12 from our values over here, right? 2 times 6 times 12 is 12 times 12. I'll just write that as 12 squared. It's 144, but we'll just leave it as squared for now. X squared times y squared times z squared equals 12 squared. So now let's just square root everything. So the square root of x squared, y squared, z squared equals the square root of 12 squared, which is just 12. It's plus minus 12, but let's just ignore negatives for now. So x times y times z equals 12. In theory, the answer could have been minus 12. I don't think they would have done that, but it could have been minus 12. Minus 12 wasn't an option. 12 is though, so that's basically our final answer. Let's just go back to our flowchart and identify the key steps which we did to make a pretty difficult problem like quite manageable. So there were two sides, the tricky side, which is just multiplying x, y, and z normally, and the good side, to write them as the square root of a minus b minus the square root of a plus b. And then we substituted a and b for all of them, and basically just worked out x squared times y squared times z squared, square root of that to get x times y times z. So yeah, that wraps it up for this video. I hope you enjoyed, I hope you learned something new as well, and I hope to catch you next time. Thank you, bye.